Thank you, Dr. Subra, Honorable CSC, distinguished participants of this event. Dr. Subrat said, would you like to deliver the first lecture? I jumped on the opportunity and I chose the topic myself. My favorite topics are climate change effect on the Himalayan and Trans-Himalayan regions. And also time management is another topic which I always, whosoever wants to listen to, I jumped on the opportunity. I had written a small note on this. You have not distributed it. Since the note has not been distributed, I more or less read out the note. Earlier I thought perhaps it had been circulated earlier, then we could perhaps confine the discussion on the points raised in the topic. Now the topic, as Dr. Subrat mentioned, is impact of climate change on India's Trans-Himalayan region. Now, frontline thinkers have found planet Earth to be a living entity. You know, the attributes of a living entity are self-organization capability, and a life cycle. It has to have a birth, it has to have a growth, a plateau, and decline, and a death. So, frontline thinkers have always thought that the Earth is a living entity. And James Lovelock, who the English environmentalist and futurist, in his hypothesis relating to planet Earth, has named it Gaia. Gaia after the Greek mythological goddess personifying Mother Earth, Gaia. So he has called Earth as Gaia, and it's a living entity. Climate change is essentially a part of the life cycle exigencies of this living entity, climate change, and weather is a sub-part of this. Now, there are both positive as well as negative impacts of climate change on planet Earth, long-term as well as short-term. These can be viewed in terms of two broad time scales, again on long-term and short-term basis. The two long-term ones are cosmic, which is in terms of billion years, and geophysical, which is in terms of million years. The living Earth and life forms on it are having to adjust to the exigencies of long-term changes through the process of natural selection after the fashion of evolution of living species. However, the short-term adverse impacts of historical 1,000-year scale and human lifetime 100-year scale are required to be managed through policy interventions of the states and societies, so as to see that either these are prevented altogether, the adverse impacts, or if it is not possible to do so, to minimize their adverse consequences. Now, where does Trans-Himalayan India stand in this respect? The Trans-Himalayan region of India comprises Ladakh, entire Ladakh, and parts of Himachal Pradesh. That's all about all. The rest is all Himalayan region. This is subject to all consequences of climate change, as you know, particularly global warming, except that it has managed to remain in the past in a complete monsoon shadow. Monsoon would never come to Ladakh in the past. The Himalayas acting as orographic barrier. The Himalayas would stop the monsoon winds from reaching Ladakh. The Himalayas constituted the orographic barrier for monsoon winds in clouds. The result is that the region has had a microclimate of its own, characterized by low annual precipitation of about 6 inches, mostly in the form of winter snow, and annual temperature variation of the order of 70 degrees Celsius, plus 35 in the summer sometimes, and minus 35 in the winter. Now this variation of 70 degrees is enormous. This has been responsible for breaking the rocks and cracks in the past into smaller boulders, and the weather, the ups and downs have broken these further down to sandy level, with the result that Ladakh had come to be known as, acquire the epithet or sobriquet of Arctic desert, high altitude Arctic desert. Deserts are usually found in the plain areas. Ladakh and perhaps some parts of Mongolia, these are Arctic deserts. This situation is believed to be the cause of desertification of the high altitude region, as a result of which the region has come to acquire the sobriquet of cold desert or Arctic desert. The source of water for habitation of the region has all along been cryospheric, meaning permafrost. In Ladakh, the yars usually have ice beneath these, which remain permanently frozen. Glaciers and snow. The arable, cultivable land is mostly and almost without exception glacial-fluvial. Glaciers have deposited the fluvial soil, and where the villages, all villages, without exception, have been situated. Alluvial deposits, again by snow melt and glacier melt, they are depositing alluvial soil, and moraines by huge flow of water. Now, specific impact of climate change on Trans-Himalayan India. Just as the Trans-Himalayan region of India has emerged over the years out of the socio-cultural shadow of the Indian subcontinent and the world, so also it is gradually emerging out of the climatic shadow of the Indian subcontinent and the world. The main reason for the latter being global warming. Over the last few decades, the region has no longer been in the total monsoon shadow, as I said, as in the past. Monsoon has been crossing the Himalayan barrier, now and then creating havoc in the region through flash floods and mud flows. Now, specific impacts of climate change consequent to global warming have manifested in the Trans-Himalayan region in the following 3 areas. Abnormal depletion of cryospheric sources of water due to melting of permafrost and recession or melting of glaciers. This is one impact of global warming. Glacial lake outburst flood. We call it LOF, glacial lake outburst floods, due to sudden sliding of glaciers into the lakes created by them. Now, this creates a lot of flooding situation. Then number 3 is widespread cloudbursts like rains during the monsoon season, resulting in flash floods, topsoil washing, erosion of cultivable land, and inundation of cultivated land. So these are the impacts of 3 impacts of global warming on Trans-Himalayan. While all 3 of these are consequences of global warming, the third is due to monsoon winds managing to cross the Himalayan orographic barrier now and then, not every year, which is also a consequence of global warming. All these are resulting in gradual change in livelihood pattern of the people living in the region. Now, many adverse consequences of of depletion of cryospheric sources of water and globes in the region have been unleashed on the Indian Trans-Himalayan region since the early 20th century. For example, in Ladakh, the Shyok River, which is a tributary of the Indus, its catchment has been the scene of 13 globes, glacial lake outburst floods between 1926 and 1933. So in 7 years, we had 13 globes in the Nubra Valley, causing huge devastation in the Shyok Basin in Nubra Valley in Ladakh, and areas downstream of it like Skardo in Pak-occupied Baltistan. These glacial lake outburst floods were caused by the north, central, and south Chongkundan glaciers, sliding into the lakes fed by them. Now, since 1933, mercifully, the Shyok system has gone and remained quiet. No further floods from it. In the late 20th century, a globe caused by Nemotso in 1972 had created havoc in the village of Nemo in Ladakh, involving heavy loss of property and human lives. Then, in the recent past, on May 7, 2015, a globe-like incident caused by the massive dam created by a landslide in Phuktal River in Zanskar River, which is a tributary of the Zanskar River, led to massive damage to bridges and culverts in the Zanskar River basin and also in the Indus basin downstream of Nemo, as well as some buildings and land both in Zanskar River and Indus basin. The forecast is that all the Himalayan rivers will gradually cease to be perennial. All Himalayan, the rivers that originate in the Himalayas will cease to be perennial, or altogether dry within the next 100 years or so, due to the drying of cryospheric sources of water, consequent upon global warming. Under these circumstances, advanced policy initiatives become imperative, not only in the Himalayan and Trans-Himalayan regions, but also in all the North Indian states fed by the rivers originating in the Himalayas. Now, advent of monsoon winds laden with heavy moisture in the Trans-Himalayan region has, however, been a late 20th century phenomenon. Before that, it was totally under the monsoon shadow. In the geophysical environment of the region, monsoon rains take the form of cloudbursts. Cloudburst is 100 millimeters of rains per hour. So, monsoon rain clouds coming to Ladakh and striking the various ranges of Ladakh create cloudbursts like rainfalls. 100 millimeters of rains per hour. So, these create havoc like flash floods and mud flows. In recent memory, monsoon rains were in evidence in Ladakh, first time in the early 1980s. I remember when I was DC in Leh, I had flown from Delhi to Leh in an Indian Airlines flight. The same clouds were right from Delhi to Leh, and it was raining heavily all over on the route. We couldn't land in Leh, we had to go back to Delhi, landed there. So next day there was flood in the Indus basin. So that was one of the monsoon clouds reaching Ladakh and shedding off the moisture in the Indus basin. And a heavy monsoon-related flood was witnessed in the Indus River basin in Ladakh in 1982. Since then, many parts of Ladakh have seen flash floods during the monsoon season. In 2007, some of you may recall it, 2010, 2015, 2018, and even last year there were monsoon-like rains in Ladakh, causing heavy damage to crops, built-up areas, and human lives. Scientific evidence suggests that Ladakh will experience further floods with the same or increasing frequency during the monsoon season in the coming years. Thus, with crossing of the Himalayan orographic barrier by monsoon winds, now and then, Ladakh has become a theatre of alternating floods and droughts. Droughts because of lack of rains and snows in winter, forcing many inhabitants to switch their livelihood pattern to new ones. This calls for policy plans to reduce vulnerability to occasional devastating floods and droughts, and gradual drying of cryospheric sources of water. In the obtaining scenario, the local people are required to be motivated to take initiatives, both for risk reduction and emergency response to manage after effects of adverse consequences of global warming and occasional monsoon rains creating devastations. Now, policy interventions required to minimize adverse effects of these global warming consequences. As mentioned earlier, the long-term cosmic and geophysical adverse consequences of climate change are taken care of by the self-healing capability of planet Earth as a living entity. It's a self-healing. The long-term ones are absorbed by the Earth itself. Scientifically, climate and weather phenomena are essentially chaotic systems. So it is impossible to predict how the climate will behave over thousands of years and how the weather would behave in a year. We can do some prediction, but accurate prediction is impossible because the system is chaotic. Scientifically, it's a chaotic system. Besides, as per Kut-Gödel hypothesis, Kut-Gödel was an Austrian scientist and climatologist. He says it is impossible to have a complete understanding of a system of which the observer is himself a constituent part. For example, no matter how intelligent your cells, your tissues and organs inside are, they will never understand what human being is all about. Likewise, human beings will never understand global Earth as a living system entirely. You may be able to predict some behaviors, but entirely to understand this would be impossible. Since we are observing the whole universe from laboratories and observatories, even to understand the universe is impossible because we are a constituent part ourselves. So you will never be able to fully understand what the universe is all about, no matter how scientifically advanced the society is. Therefore, in view of this, we are left with the option of forecasting and managing the short-term adverse impacts of climate change as best as we can. So, adverse consequences of climate change on the human lifetime scale, as mentioned earlier, are to a great extent amenable to policy interventions and human adaptive strategies, both in respect of prevention and management, as well as mitigation of the adverse implications of the aftermath. Such policy interventions and strategies could include the following. I've listed out some measures here. Disaster risk reduction measures. Now, these include mapping of geographically hazardous areas and human vulnerability to common hazards, and then integrating disaster risk reduction strategies with policy plans of concerned government agencies. Number two, regular scientific monitoring and data recording of environmental temperatures, rainfall patterns, river water levels, and seasonal behaviors of rivers, glacier recession rates, glacial lake behaviors, permafrost behaviors, etc. with a view to monitoring trends in various effects of climate change in these areas. Number 3, keeping alive the memory of past disasters through institutional mechanisms such as museums of recorded oral history, photographs and videos of floods, droughts, etc., and performing art initiatives like street skits of flood management techniques in areas having history of repeated visitations by natural disasters, like floods and droughts in the past. Now the next, if you go to the next slide, management of adverse consequences of global warming. I've listed 7 items in this. Rainwater and groundwater harvesting on scientific basis. We have no other option in view of the cryospheric coastal water drying up at a rapid scale. Then nucleating new artificial glaciers in high altitude catchments of perennial streams. Now, perennial streams are drying up because the glaciers are drying up. If you can nucleate new glaciers, like the artificial glaciers, which we have, I think, experimented in the last few years. Then banning of plantation on banks and close proximity of glacial belt water channels to prevent ponding effect in the path in the event of flash floods in the streams. Banning of new settlements or reconstruction of buildings in dry channel beds with history of or evidence of repeated visitation by floods in the past. Conscious change in land use patterns from traditional crops to crops which are more lucrative in the rapidly integrating national and regional markets. And number 7, development of attractive alternative livelihood avenues for the region's rural population aimed at preventing rural-urban migration to restrict urban population density to optimum levels. So these are the possible interventions at the level of government and society in order to prevent the devastating effects of global warming in the Trans-Himalayan. Now, need for academic study and research for informed policy intervention. Now, the G.B. Pant National Institute of Himalayan Environment has recently set up a regional center in Ladakh, and we are also now having the Ladakh University coming up. Maybe it takes a year, 2 years. We are in the process of signing an MOU for research in areas like climate change, the effects of climate change in Ladakh. And some of the research projects would be jointly pursued by the G.B. Pant Institute and the University of Ladakh. And some of these matters listed in the last 2 paragraphs will be taken up for joint research by the 2 institutes. These are the things by which we can mitigate the hardships of the after effects of floods and droughts. Thank you very much.